Welcome to Lysteric Papers. Today I want to show you an additional proof of the Atton diameter using the measurements of the proton. And the interesting thing is this will also lead to some conclusions about the proton structure. Today, not like the previous videos on the fine structure constant and the vacuum permeability, I'm not going to do a refresher. I've listed here the videos where you can actually go back and look at the theory more in detail so that you can understand what we're doing here as we go along. So, again, we're talking about the second electromagnetic wave. I've added this picture again. So let's go right to it. In the last video about the vacuum permeability, I had shown that the diameter of the Atton is 2.35 10 to the power of minus 23. And I had promised everyone that I was going to look for a second proof for the diameter of the Atton. So how do we go about doing this? We have very good experiments showing the radius of the proton. In the very earliest videos, I have established the number of attons using the method of the Planck quantum. So we also know that the proton has 1,836 times the mass of the electron. Thus, we can easily determine the number of atoms in a proton, assuming the same structure in a proton as in an electron. So I have to go through the remark that the surface structure is a little bit different than the surface structure of the proton is a little bit different than the surface structure of the electron due to some specific reasons, but I'm going to have to probably do a whole different video on this. The calculations are assuming the same structure as the calculations are assuming that the proton and the electron have the same structure, volume structure. This is an important statement, so keep that in mind. So as I said, the number of atoms in the electron have been calculated in previous papers, and it comes out to 1.23 10 to the power of 20 atoms in the electron. Another way to show that this is the correct number of atoms for electrons using the Compton wavelength, which is 2.43 10 to the 10 minus to the power of minus 12. So the formula for the the formula here 5 in the Compton wavelength is the Planck quantum divided through the mass of an electron times the light speed velocity. So, as I've shown in previous videos, the Planck quantum is nothing else than the mass of the Atton times c squared, because it's in reality the Planck quantum is an energy unit. And then, of course, the mass of the electron is the number of atoms in the electron times the mass m0, again times c. Basically, that reduces the formula to c divided by the atoms in the electron. Rearrange it to show the atoms in the electron, so that would be c divided by the Compton wavelength, and voila, you get 1.23 10 to the power of 20. So here's a second proof that that the number of atoms in the electron is 1.23 times 10 to the power of 20. So now we can go right straight to calculating assuming that we have the same structure. So we go to the proton, it's 1,836 times more mass than the electron. So all we have to do is Ne times 1,836. So we get 2.26 10 to the power of 23 atoms in a proton. So again, we can go back because the Compton frequency of the Compton wavelength of a proton, and thus we can calculate the Compton frequency of a proton, has been established experimentally. And then we can go back and say, okay, fine. That turns out that the Compton frequency is 2.26 10 to the power of 23. And again, the frequency of a second electromagnetic wave is the same as the number of atoms. So I think I've shown that in more than several ways. So this number is exactly the same number that we calculated using a completely different method. the method of calculating this by multiplying the mass times the number of atoms of the mass multiplier between electron and proton times the number of atoms. So now we have the number of atoms in a proton, which then allows us, using the volume formula, to calculate the radius in numbers, the radius of the proton in the numbers of atoms, which then is 3.77, 10 to the power of 7. Then we can take the well-established proton radius that has been experimentally pretty much narrowed down in the last 10 years to 8.77. Then we divide that radius by the number of atoms in the radius, which gives us then the dimension of the atom. And voila, we achieve 2.33, 10 to the power of minus 23, which is exactly the same dimension that we obtain using the vacuum permeability, and thus the lowest wavelength of an electromagnetic wave. So we have now two methods that establish the diameter of the atom. So we can pretty much say that the diameter now of the atom is 2.33, 10 to the power of minus 23 meters. So now we have used this assuming that we have the same structure of the proton as the electron. So that also tells us, since they both come out even, that most likely the structure of the proton and the electron are the same. In the previous videos, I had shown, using the Rydberg formula, that we have a range of radii for the electron depending on its energy state, especially when it's orbiting the nuclei. So the electron stable state probably has a radius of around 1.5, 10 to the power of minus 17. And in the fully charged state, that radius will go up to 3.29, 10 to the power of minus 16. I think that's also some of the problems that we've been having trying to experimentally determine the radius of the electron, because it is not as constant as the proton. Now, the proton does not necessarily have to be totally constant either, but the proton has a less possibilities to charge the proton into a higher energy state. So I think this result is pretty exciting. I hope you agree. In the next videos, we'll attempt to explain the surface structure of the electron and the proton. But first, we have a few other topics that I want to cover. So I hope to be back again pretty soon. And I thank you for listening in. In general, maybe if you guys like the video, press like and also press subscribe. That way, this might get out to more people, and more maybe counter arguments and counter ideas come into play, which probably might help validating this whole theory. So thanks a lot. Hope to see you soon.